which we have to reach up to. Okay, now if I take this is DE square, okay, DE square plus A square is AD square. D square plus A square, if I write 1A square here, that will give us, and A square plus C square is 1A square plus CE square is giving us AC square. No problem, but BD square we have to reach up to. Or if I write AE, okay, DE is also there, DE, okay, from this equation we will take that, no problem. Let us take this BD square as it is. So BD we have to reach up plus DE square, this DE square, if I write E square plus A square together, if I write plus, now 1AE is left here, A square, only A square is left, no problem. This is 1AE square plus CE, now can be written as CD minus DE. So CE square, which is nothing but CD minus E. Now this A square as it is, this 1A left, twice BDD we will write later. But before that, let me write here, this is CE means CD minus D, C minus D. Okay, let's take this whole square. So from here we get, this is CD square. Now D square plus A square is D square plus AE square is AD square. This is AD square plus AD square is here. Now here plus A square if I there, no problem. Plus if I open this CD minus D whole square, it will give us CD square plus DE square. Okay, one left, one thing was left here, this is twice BD, this into DE, this was left here. Now from this, CD square per D square minus twice CD into DE is also there, this is minus sign. This is A minus B whole square, A square minus twice CD. Now this twice BD, because BD equal to CD, twice BD into D is cancelled out. Twice BD, twice H, since BD is equal to CD, it's BD into CD. If BD into D and CD into D, they are same thing, because in place of CD, we are at BD, this is BDD, BDD, these two are negative positive cancelled out. Okay, let me write here. We have reached up to left hand side, we were having AB square plus AC square, no problem, because we have reached up to this BD square plus AD square is there, BD square plus AD square. Now what about AE square plus D square is further, again there is AE square plus, now CD is there, CD equal to A square per D square is written down here, but because CD is equal to BD, in place of CD square we can write BD square. Okay, so this in place of A square per D square, these two steps are there, these are written together, one CD square plus BD square, AD square, BD square, AD square plus CD square. In place of PD, I've written down here BD square. Okay, by CD equal to BD. Now let me add them. Now AE square to D square is AD square. In place of this also, and this is BD square twice BD square. We have got AD square is already there. This is also the bracket value is AD square. This is the right angle triangle. A square plus D square by Pythagoras theorem. This is AD square. This is twice common. BD square plus AD square is there. So this is known as Apollonius theorem. AB square plus AC square. Therefore, AB square plus AC square is twice BD square plus AD square. Twice BD, twice AD square. Okay, so this is how we have to prove. If AD is the median means D is the midpoint of BC, then this theorem is verified here, known as Apollonius theorem. AB square plus AC square equal to AD twice of AD square plus twice of BD square, twice BD square plus AD square or AD square plus BD square. Now this is known as Apollonius theorem. Okay, this is Apollonius theorem. We have reached Apollonius theorem. So this is in case of medians. Okay, if a median is there of a triangle, from opposite vertex we have drawn a median. Median is the side bisector. Okay, so it is bisecting the side, opposite side, and D at D point, which is BD equal to CD. BD equal to CD here. We draw the perpendicular A, and we have proved by taking Pythagoras theorem. With the help of Pythagoras theorem, we can prove this Apollonius theorem we have proved. So this G part because Apollonius theorem. Okay, that we have done. Now next is question number 4. So Apollonius theorem we have completed. Let me talk about now question number 4, which is known as, okay, one angle bisector divides the opposite side of a triangle. One thing was left that if there is a triangle, there is angle bisector here. And this is angle, let me take A, this is A by 2, this is also A by 2. Okay, so this is D point BC. If AD is the angle bisector, of angle E, then AB upon AC, then the sides which contain the angle, the ratio of them, AB upon AC is equal to BD upon DC. This is known as angle bisector theorem or proof. Okay. This is a statement which is very important to be used. The angle bisector of a angle divides the opposite sides in the ratio of the sides containing the angle. These sides AB and AC contain the angle A. Okay, so in the ratio of the sides which contain the angle A, in this case AB upon AC is equal to BD upon DC. The angle bisector of a triangle divides the opposite side in the ratio. What ratio? BD upon DC. This ratio in the ratio of the sides containing the angle. This is equal to AB upon AC. This is known as angle bisector theorem. Okay. Angle bisector theorem is AB upon AC or BD upon DC equal to AB upon AC. This is one of the theorems here. Now let us check the next point. Angle bisector theorem. But next question is angle 4. Question number 4. Let me first. Okay, take the question number 4 now. Question number 4 says, what do you mean by geometric centers of a triangle? Geometric centers of a triangle means we have to know about what is in center, what is the circumcenter. Question number 4. What are the geometric centers? Geometric centers of a triangle. Okay. Geometric centers of a triangle. We have to talk about them. It is a solution that we talk about. First one says circumcenter. What is circumcenter? Circumcenter. The B point is in center. And the C point is, what are the X centers? Excenters. Okay, these three types of centers are known as, or centroid is also there, also center. B is the eccentric, C is eccentrous. D point is what is orthocenter. Orthocenter or orthocenter. E point is centroid here. Let me now talk about these 5 points. What is circumcenter here? Circumcenter is if there is a triangle, if the midpoint, or we can say perpendicular bisector of the two sides, if I take the perpendicular bisectors, if I draw a perpendicular on this side, this is the perpendicular bisector of the, it means this is the side here. Let me take this is the point here, which is, if I draw perpendicular, or of this is BC, suppose this is A, this point is perpendicular bisector, okay, of the side, perpendicular bisector of any two sides if I draw, or we can say that if I draw the medians of the triangle, medians means if I take the medians of the triangle, so this is the median here, this is the median here, and this is the median here. And this point known as circumcenter here, suppose if I take this is C point here, circumcenter. So CA, sorry, not CO, let me take for CR, take this. Okay, this point O, where OB is equal to OC equal to OA. Here OA is looking like a very distant point. Sorry. So this is, we take this point is here. This is A point here. Okay. And this is the B point. This is A point here. Circumcenter is a circle with taking a center inside the circle, inside the triangle. We draw a circle which is passing through the three angular points. Okay, so what we do, one thing is that we have to draw perpendicular bisectors of any two sides. That is, two sides of the triangle like this one. If I draw perpendicular bisector of this side, which is suppose the perpendicular bisector, this is midpoint here. This perpendicular bisector of this line also here. Perpendicular bisector of this line. These two are meeting here at this point. I join this point to this, and then there is another point A. The perpendicular bisector of that also we can draw. If these three are meeting each other of any two sides, if this is these two sides we have taken here, A, B, C. Any two sides we can take. This point OB equal to C equal to OA. So, if let me write here, sorry. If OA, this is the O point here, is equal to OB is equal to OC. Okay, taking O as the intersecting point, of perpendicular bisectors of any two sides. Suppose third side will also meet there. Perpendicular is intersecting point of the perpendicular bisectors. The perpendicular bisectors of two sides, any two sides, of two sides of a triangle. Then these two perpendicular bisectors will meet at a point. From there, at that point, the distance of the three vertices will be same, because this is perpendicular bisector of this line passing through the midpoint. So every point, let me take here, that there is a, here these midpoints are there. This is midpoint here. If I take a line, okay, let me take a perpendicular bisect to this point meeting at the midpoint. Now this D is the midpoint of this. If I take any point from lying on the AD line from B and C, this angle, any point lying on this AD line will be equidistant from B and C point. This angle is equal to this angle. Okay, because these two lengths are equal. So this I, let me take IB is equal to IC. Any point lying on this perpendicular bisector of of BC, AD is perpendicular to the BC. D is the midpoint here. If I take D is midpoint of BC, then taking any point on the line AD will be equidistant from BC. But in this case, what we have done, if I draw two perpendicular bisectors of the two sides, this side and this side also we have drawn. Suppose this is also perpendicular bisector and this point. It means this point is equidistant from all the three vertices OC, OA equal to OB. Then it becomes the circumcenter. Circumcenter is taking O is the intersecting point of perpendicular bisectors of two sides of a triangle. Then the intersecting point of these perpendicular bisectors of two sides, perpendicular bisectors, these perpendicular bisectors of two sides will be equidistant from the three vertices. From the three vertices. Okay, that means suppose this is O point here, OA equal to OB, OA is equal to OB equal to OC. So these are the perpendicular bisectors. Okay, so of these two sides we have taken. Then this point, if I go further, this will also meet at the midpoint of AB. This is also perpendicular bisector on the third side. Okay, it means OA is equal to OB is equal to OC. So this is given as the radius of the circumcenter. We denote it by capital R. Okay, capital R is the radius of the circumcenter. Okay, circumcenter radius. So this is about circumcenter. Now in this case, if I take OA, OB, OC as a radius and draw a circle which will pass through all the three vertices. Okay, so taking OA equal to OB equal to OC as a radius of the circle, radius of the circle, which will pass through all the three vertices. Will be passed through all the three vertices of the triangle. Three vertices of the triangle ABC. Therefore, here O is known as circumcenter. Therefore, O is the circumcenter. So this is the first circumcenter. First geocenter, circumcenter. Circumcenter is first geocenter here. So the circumcenter, A part we have defined. Second is incenter. I have talked about. Now I am going to stop the topic because camera is full now. So the next B part we will talk about later. After 5 minutes time, I will talk about what is incenter, what is excenters. This I have talked about in trigonometry. What are the excenters? Three excenters are there, and taking radius of them is small r1, small r2, small r3. Because that X circle will touch the opposite side of the angle A, opposite side that is BC. from externally. I mean, externally it will touch all the three sides of the triangle, and the side BC from external side, and AB and AC extending. After extending them, the circle which is touching the three sides of the triangle externally, known as excenters. Okay, excenter. Okay, so excenter is having radius R1, R2, or R3. There are three kinds of excenters that we will talk about. In center also, if medians are drawn, or if I medians are drawn, that medians are meeting at a point O, suppose, and from there O point, we draw the perpendiculars to the opposite sides, then that distance, perpendicular distance, or let me take OD, OE, and OF, we have taken as radius. Then if we draw the circle will pass through, or that circle will lie inside the triangle. It will touch the midpoints of the three sides. Okay, or the three sides will be touched by this circle. This is known as incircle. We talk about that by drawing everything here. Okay. Graph as well as the value of the incenter. That is the point. We'll discuss about later. Let me take now. After 5 minutes, I'll take next incenter. Okay, accenters, what is also center, what is centroid. All these things we have to define from question number 4, B part onwards. Okay, then see you after 5 minutes. Okay.